All right, so today we're going to do something a little different. We are going to be doing notes at your own pace, which you guys expressed would be better because writing and trying to catch up with me is kind of stressful for you. So we're going to try it this way and see if we like it. So you may do the drawings that I do if you would like. You may do stick figures, you may do whatever kind of drawing will help you remember the notes that we're taking, and you may pause and take the time that you need, but you will only have one class period to finish this. So this needs to be finished at the end of the class period, so don't take too long on art masterpieces. Okay, so today we are going to be talking about water vapor and humidity. So at the top of your page, please write water vapor and humidity. Humidity. Okay, so where does water vapor come from? If you put a cold glass of lemonade on a table, so I'm going to draw my glass of lemonade. My glass is going to be pretty fancy. It's going to have ice cubes in it because I like my lemonade pretty frosty. And mine's going to have just a little lemon on the side because I like mine to look nice. Now, which way does that make sense, right? Maybe? No, it goes like that. Okay. Cool. And I'm going to color in my lemonade. And give it a little bit of a shadow because, like, it's a bright sunny day. Because who drinks lemonade in the winter? Okay, cool. What happens? What happens when I have this frosty glass outside in the heat? Well, usually, do you ever see this happen? We're like, ooh, now my glass is wet. What the heck is happening? Right? And sometimes, like, you lift it up and there's like a puddle of water here. Why is that? Why is there a puddle of water? It's not lemonade, so the glass isn't leaking. It's actually water. The water level in the glass doesn't drop. You still have the same amount of lemonade, right? The water isn't lemonade. So what's happening? The water in the puddle comes from the air around the glass. When warm air touches the cold glass, the air cools. Droplets of water form, run down the side of the glass, and make a puddle on the table. So when we think about air, we know there's water vapor in the air, right? It doesn't form liquid until it gets cooler, right? It gets near the edge of the glass. The glass is really cold because ice, duh, right? And so water forms and it drips down the side of the glass. Then you get this puddle of water. The water in the air is called water vapor, or as my professor in college would say, water vapor. Water vapor. Water vapor is water in the form of a gas. So I'm going to write water in gas form. Water vapor is invisible, colorless, odorless, and tasteless. The amount of water vapor in the air is called humidity. So have you ever heard of the term humidity before I wrote it on my piece of paper? Yes, of course you have. We talk about it in the weather. People say, oh my gosh, this humidity makes my hair so crazy. It's the amount of water in the air. If we're talking about hair getting crazy, you know that when girls go outside in the rain, they get upset because their hair gets wet and frizzy. Some girls at least. Oh no, my hair. This also happens when it's humid. Girls will complain about their hair being frizzy when it's humid too because there's moisture in the air. It's getting in their hair. Okay, that's a good way to remember humidity. Humidity is water in the air. Do not confuse humidity with droplets of water, liquid water you see in rain, fog, or clouds. How does water vapor get into the air in the first place? More than 2/3 of our planet is covered with liquid water, oceans, rivers, and lakes. There is also water in the ground and in plants. To get into the air, the liquid water must be changed into water vapor. The change of liquid into gas is called evaporation. So we've got a bunch of water on our planet. Okay, I'm just going to draw a little sketch of our Earth. We've got some land over here. And down here, and then we've got some down here, and then we've got some over here. We've got Australia-ish over here, and then like Russia and China and all that stuff over here. Ish, right? Okay, I'm not an artist, just pretend to be. Okay, and then here's all the water. Much more of our Earth is covered in water, clearly. Oh, I forgot Greenland. Oh no. Okay. So, the process of water becoming water vapor or evaporating, you know, like from puddles and lakes and such, is called evaporation. Changing of a liquid into a gas. Okay. The main energy source for Earth is the sun. Each day the sun turns trillions of tons of ocean water into water vapor. Water molecules absorb the sun's energy and speed up. Speedy water molecules near the surface of the liquid escape or evaporate into the atmosphere as water vapor. Some hit other molecules and return to the liquid. When air is cooled, molecules in the air slow down. The molecules of water vapor in the air also slow down. If they slow enough, water vapor molecules change to molecules of liquid water that collide and stick together to form droplets on cool surfaces. So, when water molecules speed up, it forms water vapor, which is the process of evaporation. Oh no. Okay, fit it there. Sorry, this is evaporation. Okay. When water molecules slow down, it turns back into liquid water, which is also called condensation. From vapor or gas to liquid. You can see condensation on shower doors, on cold drink glasses, and as dew on grass in the early morning. Plants' roots absorb water that has the liquid water through their, Plants' roots absorb water that has seeped into the ground. Plants transport the liquid water through their roots and stems to their leaves. The leaves then give off water in the process called transpiration. This is the second largest source of water vapor in the atmosphere. Two factors determine the amount of humidity in the air. First, there has to be water available to evaporate. Second, the warmer the temperature, the faster the water evaporates. This means that if water is available, warm air will take on more water vapor than cool air. Okay, so I want to just pause and draw out transpiration so that we remember what that is. So I'm going to do like a sunflower because I like the color yellow. So I'm just going to quick doodle. I know a sunflower has a big middle part like this. That's both brown and black. And then it's got lots of petals. And then we've got this big stalk with some leaves. Yeah? Okay, so water comes up through here. I'm going to put H2O because we know dihydrogen monoxide is water. It's dihydrogen because di means two. And so dihydrogen, 2 hydrogen, 1 oxygen. Dihydrogen monoxide, like mono, means 1. Okay? It gets sucked up through the roots. It absorbs through the roots. It goes into the plant and it goes into the leaves to help with photosynthesis. Photosynthesis is the process of changing the sun's energy into sugar through the use of chlorophyll. Okay. So the sun's energy also heats up the water that's inside the leaves. Water is released through the process of transpiration. Trans means through, we know that. The water is going through the leaves. It kind of sounds like the word perspiration, which means sweating. So this reminds me of sweating, like the plants are sweating out water. Okay, so that is the second largest source of water vapor. Second largest source of water vapor. Relative humidity is a comparison between how much water vapor is in the air and how much the air could hold at a given temperature. So I'm going to flip to my next. I'll fit it right here. I'm going to just right here write relative. I didn't spell that right. RELA, relative humidity. Comparison between water vapor present and water vapor capacity. Okay, moving on to our next clean page, we're going to start with what happens when warm, moist air cools. How can warm, moist air cool off in the lower atmosphere? The air gets colder with increasing altitude. Air can cool by being pushed upwards over mountains by winds. So let's do that one, number 1. We've got a mountain range. I'll do a little snow up here. And then clouds. Now we've got warm air going upwards. So the cloud forms. Okay, this cools air because remember when we talked about altitude, the temperature goes down as you go up. The further up you go, the less degrees Fahrenheit you're going to get. Okay? Heating the air also causes it to rise. When the sun heats the ground, air above the ground warms and rises. As it rises, it expands and cools. Okay, so we've got number 2. Got a nice bright sunny day. And this cloud forms because we've got the ground that has lots of moisture in it because there's lots of grass on the ground, and there's some trees over here in the far distance. So water is in this warm air that goes up into the clouds because the sun is heating up the ground. It cools down and expands into these clouds. Okay. Next, air can also be pushed upwards when cool air and warmer air meet. When the two meet, they don't mix. The lighter warm air is pushed up over the heavier cold air. As a result, the warm air pushed higher into the atmosphere cools. Okay, so this is what's happening in the third situation. We've got a very similar situation to the second. However, let's pretend like it's springtime, kind of like it is right now. We've got the trees, we got trees over here, and we got a sunshine-ish. It's not as big as before. Maybe it's not so warm. Okay, so we've got some cool air coming in this way, yeah? Cool air. But we have some warm air that got heated up. Now, we know that warm air rises. Okay, we know that because when we go in the basement, usually we're cold. When we go up into the attic, it's usually pretty stinking hot. Yeah, so warm air rises as the cool air comes across and hits that warm air. When the warm air rises, it goes higher into altitude and it cools down and expands, and so a cloud forms. In each case, the end result is the same. As the air rises, it cools. The water vapor in it condenses into tiny water droplets, forming clouds. If the temperature is below freezing point of water, its water vapor will form a cloud of tiny ice crystals. In order for water vapor to condense, it must have a surface on which the liquid droplet or ice crystal will form. This surface is provided by tiny dust particles in the air. You will learn more about clouds in the next lesson. All right, so that is it. Once you are finished with this, I'd like you to go back and watch this video. You can put the address into your web browser. Go ahead and watch this video. And when you're finished with that, you may go on Prodigy to do our Math Madness. All right, get to work. Thank you.